All right. So been a little while since we had a video, okay, over a week. So we're now going to be starting Unit 2, which is now we've learned about sine and cosine in the unit circle, and now we're going to translate that to actually graphing these. Okay, and so we're only going to focus on sine and cosine graphing. All right, because they're very important, because they're going to eventually help us when we do some real world problems. Help us to be able to understand how to solve those as well. Okay, so if you are using this to understand the lesson, you need to have your unit circle filled out, okay, in front of you. All right, all this information up here, guys, came right from the unit circle. Okay, so all I did was in radians, I labeled all these degrees in radians. Okay, and then the actual, what is sine equal to at 0 degrees? So sine's equal to 0 at 0 degrees. Sine's equal to 1/2 at 30 degrees. Sine's equal to root 2 over 2 at 45 degrees. Sine's equal to root 3 over 2 at 60 degrees. And sine is equal to 1 at 90 degrees. Okay, and I just kept going along. Okay, and you kind of start seeing a pattern here. 0, 1/2, root 2 over 2, root 3 over 2, 1, root 3 over 2, root 2 over 2, 1/2, 0, negative. Now, again, why am I getting negative answers here? Because in quadrants 3 and 4, sine is negative. So pretty much we are doing a rotation around the unit circle, but we are charting it out as a graph. Okay, and then this last row here is just all these values. 1/2, this is equal to 0.5. It's just all these values as decimals, so it's a lot easier for you to graph. Okay, and so what you are looking at right now is that the radians were all my x values. See where all these lines are? I just plugged it in. So you have 0, pi over 6, pi over 4, pi over 3, pi over 2. I didn't finish writing them all out. I thought it would be very tedious. Okay, I think you guys can understand. You're just following along. That would be 2 pi over 3, 3 pi over 4, 5 pi over 6, and then you eventually get to pi. Okay? And then the y-axis is labeled, 0 going up by 0.5, so 0.51. Okay? And so what you are looking at right now, guys, is the graph of sine equals x. Sine equals x. All right? And the biggest thing you need to understand first is okay, that this graph is cyclical. And so what that means is that it cycles through. So look where it starts here. Okay? Its behavior. It starts in the middle, goes to its highest point, back down to the middle, then goes to the lowest point, and then back to the middle where it all started before. Then look what happens again, your next cycle. Back to the highest point, back to the middle, back to the lowest, back to the middle. And so we call this y equals sine x behavior as middle, high, middle, low, middle. That's 5 points. That's our 5-point method that we are going to be using starting class next Tuesday to graph these. Okay? So a couple of key things you understand is that since these are cyclicals, they all have a period, right? That period is equal to 1 cycle. Okay? So period is 1 full cycle. All right. Right now, we're not going to talk about phase shifting, which is the graph left to right. So it's really easy to determine what that period is. Well, you started here at 0 and you ended at 2 pi. Okay. So 1 full cycle of sine is just equal to 2 pi. Okay. The domain. Okay. Now the domain is all x values. All x values. Okay. And so since this is cyclical and it's going to keep repeating over and over again, our domain is just going to be equal to all real numbers. Okay, our domain is going to be equal to all real numbers. All right? The range. Okay, the range, which is all the y values, right? So if you look on here, okay, it looks like my max is at 1 and my minimum is at -1. Again, we're going to shift this up and down, okay? But for the parent function, your range is always going to be a max of 1, a minimum of -1. Now, we are including both of those points. So when I write my range here, okay, I'm going to bracket it. We're going to say -1 to 1. Okay, -1 to 1. All right? Okay, the x-intercepts, all right? Where is it crossing the x-axis? Looks like 0, pi, 2 pi, 3 pi, 4 pi, okay? And so what that means is, okay, what that means is that all of our x-intercepts are occurring at n pi. And let me explain what that means, okay? Where n all right, I never can write this correctly, I apologize. Which really isn't that too hard because it's like a sideways E. Okay, can be any integer, so all integers, right? So what that means is something like this, right? So all my x-intercepts 0, pi, 2 pi, 3 pi, 4 pi, and it just goes on and on and on, okay? And so what you need to understand is that when it's in its original form, its parent function, all your x-intercepts, all you're going to do is you're just going to add pi to it. So you have 0 plus pi gives you pi, pi plus pi gives you 2 pi, that type of thing, okay? It's just where does it cross? And it crosses at every pi, okay? So you just add pi to it to get to the x-intercepts. Now, the y-intercept, okay, where does it cross the y-axis at? Okay, where does it cross the y-axis at? And in this case here, it's just 0, 0. Okay, the only spot it's going to ever hit the y-axis at is at 0, 0. It starts in the middle. Starts on our x-axis. Goes high, middle, low, middle. Okay, that's our behavior for sine. Okay, our maximum value, where does that occur at? At 1. Okay, and so then if we wanted to write a rule for that, where does it first occur at 1 here? At pi over 2. So I'm going to do pi over 2 plus, where does the next time the max occurs again? At 5 pi over 2. Well, if you were to do 5 pi over 2 minus pi over 2, that would give you 2 pi. So every 360 degrees from pi over 2, we get our max value. So then if you were at 5 pi over 2 and you added another 2 pi to it, which is 360 in radians, you would then get your next max value. And so we write it like this. We do pi over 2 as 2 pi n. Okay? Again, right, where n can be any integer. Okay? So, and guys, don't worry about the formulas too much, okay? I'm just trying to kind of explain it to you, right? So that you have an understanding, all right? The formula is just really not important. You just need to understand about the max and the min, right? So pi over 2, 5 pi over 2, 9 pi over 2. You kind of get the point here, and it just keeps going on and on. Okay, every 2 pi. And now the same can be said for our minimum. What's our minimum value here? -1. And where is that first starting at? That's starting at 3 pi over 2. So then we're going to do the same thing. We're going to do 3 pi over 2 plus 2 pi n. Because look what's happening here. The next time it gets to a minimum is when we have gone a total of 1 cycle, or 2 pi. Okay? And so same thing here is when we write out is that any integer. Okay, 3 pi over 2 plus 2n, n can be any integer. So again, we write it as 3 pi over 2, 7 pi over 2, 11 pi over 2, and so on. Okay? And so that right there is our sine graph. Okay, our sine graph. Again, behavior, middle, high, middle, low, middle. You're going to hear me talk about that a lot. Okay? All right, let's flip it over to the back for cosine. Okay, so cosine, very familiar look. Okay, again, where did I get all this information? This is 0 degrees. 0 degrees in radians is 0 degrees, 30 in pi over 6. Okay, I'm not going to bug you with all that. All right, what is cosine equal to at 0? It's 1. What is cosine equal to at 30 degrees? It's root 3 over 2. Where's cosine at 45? Root 2 over 2. Cosine at 60, 1/2. Cosine at 90, 0, so you got to get the point. And again, why are we getting negative values here again? Because in quadrants 2 and 3, cosine is negative. Cosine is negative, so we should have negative values for this. All right? So this right here in front of you is the graph cosine y equals cosine x. It's the parent function for cosine x. Now, look at the behavior here, though, for cosine, okay? Cosine now starts at its highest point. So its cycle for cosine starts at its highest point, then goes to its middle, then to its lowest, then back to its middle, then back to its highest, and that's where it then starts over again. So we call the behavior for cosine as high, middle, low, middle, high. That's our five-point method that we are going to use starting next Tuesday to help us graph these. Okay, 5-point methods at our quadrantals. Okay, it's 0, pi over 2, pi, 3 pi over 2, 2 pi. Those are all our quadrantals. Very easy to graph. Going to make these more simplistic to graph than having to graph all of these points. Okay? And so then now that you see this, again, so this is where they're different between sine and cosine. Sine starts at the middle, cosine starts at the top. Okay, at the maximum value. Whereas sine starts in the middle. Okay? Again, it's cyclical. High, middle, low, middle, high. Okay? And then you start back here again, high, middle, low, middle, high. Okay, so this right here is 2 whole periods of your cosine graph. All right? So again, what is the period for this graph? Well, we started the high point at 0 and we ended the high point at 2 pi. So therefore, that total distance is a matter of 2 pi, or 1 revolution around the circle. Again, just like sine, the domain is going to be all real numbers. Okay? The range, same thing, nothing has changed from that. It's just going to be our lowest point is going to be at -1. Our highest point is going to be at 1. Okay? My x-intercepts, okay, have changed now a little bit. Okay, they've changed a little bit. Now, instead of being at pi, adding pi to it, they now start at pi over 2. So we're going to say pi over 2 plus, okay, plus n pi, again, where n can be any integer. Okay? So if you wanted to know, okay, second cycle, what would be my intercept? I would just do pi over 2 plus 2 pi. Okay, and so on my second cycle, remember this is my first cycle here, right? Okay, my second cycle, well, pi over 2 plus, anyway, sorry, I mixed it up. Don't listen to that. Sorry, just don't worry too much about the formula. Just know that starting at pi over 2 is your first x-intercept, and that you're going to constantly add pi to get to your next x-intercept. That's the biggest thing you understand. Sorry, I apologize about that gap. Okay? Now, our y-intercept, where does this cross the y-axis? Well, this time it's a little bit different. So here's another difference from sine. Okay? From sine. Because that's your y-intercept now is going to be at 0, 1. Okay? Instead of 0, 0, because again, cosine starts at our high point. And we'll actually talk about this more week 2 of this unit. Week 2 of this unit when I'm doing, when we're talking about phase shift. Okay? So we'll talk about this more then, right, when we talk about phase shift. That cosine is actually phase shifted to the left, pi over 2. Otherwise, cosine and sine would be the exact same looking graphs. The exact same. And so we'll talk about phase shifting more, which is shifting the graph left to right, but that is for week 2 of this unit. Okay? So again, where's my maximum value occur? It occurs at 1. Okay, this time it's a little bit different. Okay, it's a little bit different when we come up with our formula here. Where is that occurring at? It's actually occurring at 0. Okay, so it's occurring at 0, and then we recall that for every, how do we find our next maximum value? We're just going to add 2 pi to our starting point. Okay? All right. So then it's going to be, maximum value starts at 0, then it'll be at 2 pi, 4 pi, okay? I'll label it right here for you. So 0, 2 pi, 4 pi. You kind of get the point. It's going to keep going. 6 pi, 8 pi. It's just going to go on for infinity because it's cyclical. It keeps going on and on and on. Okay? Think of it as the weather, right? Our whole year is cyclical, right? We go summer, fall, winter, spring. Again, summer, fall, winter, spring. Okay? So there's a lot of examples of that. So I really like this unit, especially when we get to our real world problems, because you kind of have an understanding of that, wow, this is actually math that has some relevance as of right now. Whereas a lot of it's just the beginning, and so you don't have too much of that yet. Okay? All right, minimum value, -1. Where is that always occurring at? That's starting at pi. So same thing, we're going to start at pi, and then we're just going to constantly add 2 pi to it. And of course, n can be any integer. That's what this means right here. Okay, you're simple, and so it would start at pi, 3 pi, 5 pi, right? And it would just keep going on and on and on, right? So 5 pi, 7 pi, 9 pi, 11 pi, you kind of get the point. Okay? So the point of today was really just to get an understanding of what these graphs look like, right? What is a period? What does it mean to be cyclical? Okay? So that you could kind of have an understanding of what your graphs are going to start looking like come Tuesday when we actually start graphing these. Now, like I said, we're going to use the 5-point system, okay, to help us graph these. You're not going to have to graph 10 to 15 points for each one of these, okay? It's going to be 5 points, and trust me, when we get to it, it will not be too difficult, okay? It will be a little bit more when we add in phase shift and vertical shift, but for now, this first week, we're going to be taking a little bit slow, all right? And so that's it for me today, guys, all right? I will see you at class on Monday. Thanks.